This is the third part of solving a system of linear equations using elimination, which is the task connected to the task 5.9. We've already done a first example. We've now completed a second example, and we're now going to do a third example. So each example, things are getting a little bit more complicated. So in our third example, example 3, we're going to solve a system of equations, 3x minus 6y equals 3, 5x plus 4y equals negative 9. In our first example, we had something about either the coefficients of either the x or the y. They were the same but different signs. Nice. Could add them, straightforward. In our second example, we had two equations that were that I needed to change one of the coefficients for one of the variables in order to make it work. In this case, I can't just change the coefficient in front of the y or the x to make it match the other one. I actually have to do a little bit more legwork than that. So in this instance, I'm going to try to get rid of the x variables, eliminate the x. So the first thing I'm going to do is I'm going to again label my two equations, a and b. I then note that if I could somehow get 3x to be 15x, and somehow get 5x to be negative 15x, things would cancel really nicely. So I can get the 3x to be 15x by multiplying by 5. So I'm going to say 5a. And I've got 5 times equation a. I distribute the 5 through to each and every piece. And there's equation 5a. Now I'm looking at equation b, and again I want this 5x to actually be negative 15x, and I can do that by multiplying equation b by negative 3. So I have negative 3 times equation b, which is 5x plus 4y equals negative 9. I distribute my negative 3 through, so I get negative 15x minus 12y equals positive 27. So I'm now in this lovely place where I have the coefficients in front of x are the same number but different signs. So I'm going to do the work of adding them. So 5a plus 3b. 5a minus 3b. Which is what I have right here, or plus negative 3b. So I take my 5a, and that's 15x minus 30y equals 15. I take my negative 3b, which is negative 15x minus 12y equals positive 27. And I then add the equations. My x's cancel. 15x minus 15x is 0x. I add my y's, that gets me negative 42y equals, add 15 and 27, gets me 42. I divide both sides by negative 42. That gets me my solution for y. Y is negative 1. Again, I need a point, an x and a y, so now I'm going to have to substitute in this y value into one of these two equations. So let's plug y equals negative 1. We'll plug that into equation A. So then I have 3x minus 6 times negative 1 equals 3. It's 3x plus 6 equals 3. I subtract 6 on both sides. This gives me 3x equals negative 3. Divide both sides by 3, and that gets me x equals negative 1. So then I can write my final answer as the point -1, -1, x, y.